What's up, mathematicians? So for today's session, we will talk about integral calculus. So there are two types of integral calculus. That's indefinite integral and the definite integral. So indefinite integral, it likes down one of the rule, which is the general power rule that we need to discuss this time. So I have also listed here its formula for the general power rule, which is f of x to the power of n times f prime of x times dx is equal to f of x n plus 1 over n plus 1 plus c, wherein our c right here is a constant. Or to make this formula easier, let's have this one. Integral of u to the power of n times the derivative of u is equal to u n plus 1 over n plus 1 plus c. So I've already here an example. Integral of square root of 4x minus 3 dx. Since this is in a radical form, we need to make it simpler para inig-solve na to. Dili na complicated. So, let's make it into an exponential form. 4x minus 3 to the power of 1/2 dx. So, first step good in this rule is that we will going to find the value of our u. And for us to know what's the value of our u, so this will be the value of our u right here. So, therefore, u is equal to 4x minus 3. After finding the given value of u, is that we will going to find the derivative of our u, which is automatically, as what we learned in our past discussion, that if we have this one, our derivative is 4, since it is already in a 0 because it's constant. After finding the value of our du, next thing is that we will going to find the value of our dx. This one, I want to clarify this one. Since we will going to multiply this one and this one, so we have 4 times dx, we have 4 dx times du times 1 here, du. I mean, not here. I'm so sorry for the errors. So, to find the value of our dx, we need to divide this one with 4 because we need to find the value of our dx. So divide this one with 4 and this also 4. So the value of our dx is du. Since this already have a whole number here which is 1, so the value of our dx is 1/4 du. Okay, so next is that we will going to apply this one to our next process. Since we already know on how to get our dx, so kani man ni siya, mao man itong whole number. So, in our past discussion of our indefinite integral, we need to put it outside. We need to ato ni siya ilahi or ato ni siya ibutang sa atubangan ang ato ang whole number. So, we write it this way, 1/4 integral u which is our exponent, copy our exponent 1/2 times our du. So therefore, we will now going to apply the exponent form, which is 1/4, I mean the exponent rule. 1/4 integral u 1/2 plus 1 over 1/2 plus 1 plus c. Since our du here is already c na lang because we already put our 1/4 here, okay? So next thing, 1/4, we need to simplify our exponent. It is not, dili na nina to siya kopihon dere. Okay, we need to put ko na lang, multiplication sign. So, 1/2 plus 1 is automatically 3 over 2. Over 1/2 plus 1, 3 over 2. Let's copy the constant. Is equal to, since our denominator is in a fraction form, we need to simplify this one through a reciprocal. So, 1/4 times u to the power of 3, 2 times 2/3. Since the reciprocated form of 3, 2 is 2/3 plus c. So, 1/4 times u to the power of 3, 2 times 2, 3. It's just simply 2, 3 u 3 over 2 plus c. Since our u here, ato ra ning gigamit ang u dira para dili kay complicated. Kay dili ra man na siya hilabdan. So, for our final answer, we will now going to substitute the u with its original value. So, is equal to 1/4 times, which is the value of u, 4x minus 3 to the power of, how much is this one? 3, 2 plus c. Well, we almost forgot to simplify these fractions right here. So, it's not 1/4. It's 1 times 2, 2. 4 times 3, 12. So, its lowest term of 2 over 12 is 1/6. It's 1/6. So, our final answer is 1/6 times 4x minus 3 to the power of 3 over 2 plus c. Okay, so for better understanding, let's have an example number 2. Example number 2. So, we will have a given of integral of 2x plus 1 times 2 dx. So, our first process, or our first step, is to find the value of our u. And in this given, the value of our u is 2x plus 1. 2x plus 1. We need also to find the value of the derivative of our u, since 2x plus 1, the value of our derivatives of u is automatically 2. And we need to find the value of our dx, du over dx. So we need to cross multiply. So du is equal to 2 dx. Since we will going to find the value of our dx, we need to divide both sides with 2. Cancel out. And our dx is, since what I said earlier, na this one here is already have a one whole number, so the value of our dx is 1/2 du. So after getting the value of our dx, we need to proceed to our equation. So since integral u squared times our value of dx is 1/2 du. Since it is a whole, a constant number, we need to put it in front of our integral sign. So 1/2 times the integral of u to the power of 2 plus c. Automatically, let's plus constant on the end of our term, or after this, after the u to the power of any exponent. So after this one, we need to proceed to the exponential form. So 1/2, it's already not advisable to use this, so times u2 plus 1 over 2 plus 1 plus c. So let's simplify our exponent. 2 plus 1, 3 over 3 plus c. So let's have now our, okay, so since our I know that we already, since what I said earlier, na in every variable there's always a one whole number. So it is equal to 1/2 times 1/3 u to the power of 3 plus c. So since we have already two whole number, we need to multiply this one. So therefore, we have 1 times 1 equals 1, 3 times 2 equals 6. So 1/6 u to the power of 3 plus c. So for our final answer, we need to substitute u to our given u. So our final answer goes like this: 1/6 times u, which is 2x plus 1, 2x plus 1 to the power of 3 plus c. So that's it. I guess, I hope that you learned a lot on our session for today. See you on our next video. Goodbye and God bless.